All right, we are on the last page of the final exam review. For number 62, it says identify these as an acid, base, or something that's neutral, and then draw out what happens when it's dissolved in water. Well, you should recognize by now that if you see a hydroxide ion, that is a base, because this is going to get pulled apart since it's ionic by water, and you're going to be putting these two hydroxide ions into solution. That's a dead giveaway that is a base. These two both start with an H. That's a dead giveaway that it's an acid. Acids donate their H plus into solution. This is what makes an acid an acid. And then the anions are just left again because they're being pulled apart by water. This is just neutral because when NaCl dissolves in water, it doesn't produce a hydroxide ion nor a hydrogen ion. And water is both an acid or a base. It can act as either. 63, determine the pH of each solution. I want to remind you that when you see a hydrogen ion concentration written out, this could have also been written like this, that pH is equal to the negative exponent. So for this first one, the pH is 5. And if you write it out, it's always one more than the number of zeros after the decimal. If something has a pH of 5, that's an acid. It's less than 7. If the hydroxide concentration is listed, personally I find it easier to figure out what the hydrogen ion concentration would be, and these exponents add always to negative 14. So here this one has a pH of 2, also an acid. Number 64, which one has a bigger H plus concentration? Something with a pH of 9 or something with a pH of 2? Well, this one has a very small hydrogen ion concentration because this is a base. So the answer would definitely be a pH of 2. Although you can also write it out. Here's the hydrogen ion concentration for a pH of 2, and here it is for a pH of 9. As you can see, this is a much bigger number. Predict the products of the neutralization reactions is next, and balance. These are double displacement reactions. So now K is going to be with the CO3. K's got a +1 charge, CO3 is a -2, so that's K2CO3. And now H is with OH, so you can just rewrite that as H2O. And this is not balanced, K2, so we need a 2 there. Then we've got 4 H's, so we need a 2 in front of the H2O. Next one, same thing. H is switching places with Ca. Now Ca is going to be with Cl, so CaCl2. And H is going to be with OH. This one is already balanced. NaOH switches places with that H. The NaMine switches places. So now Na is with SO4. Check charges, it becomes Na2SO4, and this is water, HOH or H2O. It doesn't matter how you write it. And then it's not balanced. You need a couple of 2's to balance it out. Letter D. How many moles of H2SO4 would it take to neutralize 8 moles of OH? Well, I'm going to write out these 8 OHs. I'm writing out each mole represented with 1. And then point out that 1 mole of H2SO4 can actually satisfy 2 of these guys. Because remember, to neutralize, H and OH cancel each other out and just makes water. So how many H2SO4s do you need to satisfy these? So there's a second one, there's a third one, there's a fourth one. So the answer is you only need 4 moles to neutralize. Now, if you didn't like thinking about it that way, you like the mathy way, you can also start by writing, okay, you've got 8 moles of NaOH that you want to neutralize. For every 1 mole of NaOH, you only need a half a mole of H2SO4. So 8 times 0.5 is 4. Or you could have done this where you have a 2 on the bottom and a 1 here. You need twice as many moles of NaOH as you do the H2SO4. Either way, it works out to be the same, 4 moles of H2SO4. And last but not least, we've got 2 more things. First, for 66, write out what happens when you add an acid to water and you add a base to water. So acids donate. So this is going to become NO3 and H3O+. Bases accept. So if you write out that H2O is HOH, that H is getting ripped off, and what are you left with? OH. So this becomes HCO3 minus, and it becomes OH minus. You can see why this is a base and why this is an acid. It's putting H plus in solution. Now we're on titrations. First step in a titration is always to write out the balanced equation. So here we've got H2SO4, and we're neutralizing it with NaOH. So what's going to happen is we're going to form water, and we're going to form Na2SO4. If you check those charges, they crisscross. 2, 2. Second step in a titration is write what you know underneath each chemical. It says we're trying to neutralize 14 milliliters of a 0.75 molar acid. And we're neutralizing a mystery concentration of 38 milliliters of the NaOH. The one you know 2 things about. Multiply them. Molarity times liters. This is going to tell you how many moles of H2SO4 you had to add to neutralize your mystery. For every 1 mole of H2SO4, you're only neutralizing, or you are neutralizing, 2 moles of NaOH. So you must have twice as many moles of NaOH in there. That's 0.021 moles of NaOH. And then to figure out the mystery concentration, you were working with 0.038 liters of it. Moles divided by liters tells you the mystery concentration of that base. Okay, 68 is another one that's very similar, different reaction. This time we're adding HNO3 to calcium hydroxide. Still going to make water. And this time we're going to make CaNO3 too, if you crisscross those charges. So to balance, we're going to need a couple of 2's again. This time we're neutralizing 14.2 milliliters of a 0.014 molar solution. And we started with 24.6 milliliters of this mystery concentration of base. Same steps. Multiply the molarity times liters to tell you how many moles of acid you were neutralizing. For every 2 moles of the acid, there was only 1 mole of base in there. 0.0001 moles of CaOH2. Last step, what was the mystery concentration of that base? Divide by how many liters you were working with. Final answer, it was a 0.004, pretty weak, molar concentration of the CaOH2. Finally, our last one. It's got a slight twist, but otherwise it's pretty much the same. This time we're working with HCl, and we are neutralizing it with AlOH3. We're going to make water, of course, and we're going to make AlCl3. So to balance this, you need a couple of 3's. Write what you know underneath each. This time we had to add 12.2 milliliters of a 0.25 molar solution of acid to neutralize, well, we're trying to calculate the volume this time. how much would we need to neutralize a 0.12 molar base? Liters times molarity. This is how much you had to add to neutralize that base. But for every 3 moles of HCl, there's only 1 mole of AlOH3 in there. So that comes out to be 0.001 moles of AlOH3. How do you figure out how many liters you would need? Well, to get liters, you do moles divided by molarity. 0.001 divided by 0.12 is 0.0083 liters. How do you get that into milliliters? Multiply by 1,000, and now we're talking about 8.3 milliliters of the 0.12 molar AlOH3 would be required to neutralize that acid. And that is it for the